Good afternoon and welcome to Lowdon Digital F5 101. So F5 is the name of a company. They produce network devices and they also produce security and application delivery controller appliances, which is what we're going to focus on today. ADC. This gives you a load balancing facility, it gives you a security offloading of SSL facility. You can actually inspect the traffic with with the application security module installation if you want. There's a whole load of features available, but we're going to focus on the LTM module, the Local Traffic Manager module, which in effect gives us the load balancing. Now, what do we get with LTM? There are a number of objects we can create within the LTM module. We're going to look at the basic concepts today. The first of those is the virtual server. Now, the virtual server is an object which has a number of attributes. One of those attributes is an IP address. Another of those attributes is a port number. This is your bog standard basic load balancing type of setup. We have an IP address which is presented and a port number presented to your clients connecting to your service. Behind that single IP address and port number, we can have any number of servers or locations providing the service. But this is the public face of the service that you're load balancing, the IP address and the port number. There are also a number of profiles associated with the virtual server. And these profiles specify the shape, the nature of the traffic which will be arriving at the virtual server. So, and there are a number of predefined profiles already, or you can customize these with your own. So one of the profiles will be for the protocol. Is it UDP? Is it TCP traffic? And within these, again within TCP profile, there are a number of TCP standard profiles. There's the standard TCP profile. There's a fast layer 4 profile, which doesn't terminate the handshaking and any TCP connectivity on the actual F5 appliance. That just forwards them to the whichever pool member the load balancing algorithm chooses. As well as this networking profiles, as well as those, the two other most common profiles we'd use would be the client SSL profile and a server SSL profile. These can be used for offloading SSL connections. So weirdly, when the F5 is acting as a server, it utilises the client SSL profile, and if the F5 is acting as a client, it will then look at the server SSL profile for its configuration settings. So they seem as though they're named the wrong way around, but you get used to that after a while. And that they're the main areas that we need to be concerned around with the virtual server, I guess. You can extend the functionality of a virtual server with a thing called an iRule, which isn't part of the virtual server. It's another object we'll go into later, but you can add these, you can define your own iRules. So you can say when traffic is received on a virtual server, then let's insert an HTTP header, let's change a value already there, let's log the traffic that we've received. There are all sorts of things we can do with an iRule, but we'll cover that later. For the moment, the takeaway attributes to consider for virtual servers are IP address, port number, profiles, UDP, TCP, various TCP profiles you can go for, the client SSL and the server SSL settings if you require them. There is of course as well a persistence profile which can sometimes be handy. If you're load balancing a service which has a which is a stateful service, which, if you have people logging into the service and they need to maintain a session, then there are a number of persistence profile settings you can have, from source IP address. You can insert cookies, you can look for cookies which are already present that your application software may use. A number of persistence profiles which we look into later on in more depth. But for the moment, that covers our virtual server and the basics, enough to get you started with. Once the traffic has arrived at your virtual server and all of your specified profiles have been applied, then the next stage is actually the balancing process, forwarding the traffic on to wherever it is you want to forward it on. And we do that with an object called the pool. So we have the virtual server, which is the front end of your loads balanced service. That then feeds into a pool, and that pool can be any number of back-end servers which the traffic will be balanced across. Like the virtual server, the pool has a number of attributes which are important. The first key attribute for the pool, I guess, is the load balancing algorithm, LBA, load balancing algorithm. Now, the load balancing algorithm will dictate how you will balance the traffic that comes in around the various pool members or endpoints that you have in your pool. So there's the standard default one, I guess, that everybody knows, round robin, where traffic coming in will go to requests come in. It'll just look at it, it'll enumerate the pool members, send the traffic to the first pool member. Next request comes in, send the traffic to the next pool member. Next request, next pool member, next request, next pool member, and then cycle around back to the first pool member again. That's a fairly unintelligent, simple balancing technique which works fine if all your nodes are the same size. However, if in this instance, if we had one node which was 5 times the size of the other 3 nodes, we'd be sending the same amount of traffic to each node. So which I guess isn't a thing you would want to do. It's not being most efficient use of that large node. It's only handling the same amount of traffic. So your traffic then is going to be throttled by the smallest node that you have. The weakest node in the group is going to be limiting your throughput. In order to get around that, what you can do is use the my personal favourite, and I guess the one recommended by F5 as a start off, is the least connections. Load balancing algorithm. So in the least connections method, what we do is we start the service, traffic comes in, first request will go to pool member 1, so that will make a connection to pool member 1, another connection will come in, it'll then look at the pool's members, who has the least number of connections. Well, pool member 1 has 1 connection, so it'll send the next request to pool member 2. Another request comes in, looks at the pool group, who has the least number of connections, pool member 3 and pool member 4, but it'll send it to pool member 3. Request comes in again, who has the least number of connections, that's pool member 4, send the request to pool member 4. Another request comes in, now second request, who's got the least number of connections, they've all got 1 connection still persisted, so it will send this request to pool member number 1 again. Now in the time that we've sent that second request to pool member number 1, if pool member number 4 is 5 times the capacity of the other 3 pool members, pool member number 4 could have satisfied its initial request. So when the next request comes in, who's got the least number of connections? Remember, least number of connections? Request comes in, pool member number 4 doesn't have any connections. So in round robin, we would have sent a request to pool member number 2. But as we've used least connections now, we've sent it to number 4. Number 2 is still busy. Number 4 is sitting doing nothing. So that's a more efficient use where you have an asymmetric balance of capacity across your pool members. So least connections, there are at least two different kinds of profiles for least connections. You can have least connections pool members, or you can have least number of connections for the nodes. So you define the pool members themselves are actually defined as nodes. So what we would do is we would say, if we think of nodes, so we would define all of the endpoints as node 1, node 2, node 3, node 4. Each of those nodes has attributes again, so it would have an IP address, and there'll be some sort of health checking going on to make sure that the node's up and available. So we define the nodes, and then when we create the pool, we allocate nodes to the pool. So each of these nodes could be reused. So we could say this is pool 1, virtual server 1. We could create another virtual server 2, pool 2, and we could put the same nodes in that pool as well. So this could reference the same 4 endpoints, the same 4 servers. But with least connections pool member, what will happen is, as the requests come into virtual server 1, it will look at how many requests each node in the pool has for pool 1. So in this instance, if we start again, request 1 comes in, goes to pool member 1, request 2, pool member 2, because nobody has any, because pool member 2, 3 and 4 don't have any connections. Request 3, pool member 3, request 4, pool member 4. Request 5 comes in again, pool member 1, pool member 4 has now serviced this request. Request 6 comes in, goes to pool member 4. Now that's with least connections pool, because that's based on how busy the pool members are, these individual members of pool 1. But pool 1 and pool 2 are using the same nodes, just different port numbers, maybe, as defined by the virtual server. Virtual server 2 is obviously some different port of virtual server 1. Now if we use least connections node, then what we'll see is request 1 comes in, virtual server 1 goes to pool member 1. Request 2 comes in, pool member 2. Request 3 comes in, pool member 3. Now a request comes in for virtual server 2, goes to pool member 1. Virtual server 2, pool member 2. Then now virtual server 2 gets bombarded with requests, so loads of requests come in. So we end up with each of the pool members has lots and lots of requests and connections. Virtual server 1 isn't getting an awful lot of traffic at all, but now because we've said least connections node, it's not looking at how many connections we have in the pool, it's looking at how many connections the individual nodes have in total. So that's for pool 1 and pool 2. So now we would look at this and we would say, well, we've got 1 connection in pool 1, 3 connections in pool 2, so that node has 4 connections. We've got one connection, 3 connections, that node has 4 connections. 1 connection, 3 connection, that node has 4 connections. But we can see there are 5 connections for pool member 4 in virtual server for virtual server 2. So that node has 5, the other 3 nodes only have 4 connections. So even though that pool member has no connections, the underlying node has more than the other 3 nodes do, so the request would then go to pool member 1. So if you look at that pool, it would look as if pool member 4 for that pool isn't servicing any requests. That's because it's handling a lot of requests as part of a different pool on a different virtual server. So you can see from that you can very easily, very quickly set up a load balance service, but you can also very quickly, very easily tie yourself in knots so long if you don't keep track of which pool members are in which pools servicing which requests. So that's a key point to remember about pools. It is one of the pools are one of the simplest and probably one of the easiest places to go wrong with load balancing. Whereas the virtual server is complex, a lot of attributes. Pool doesn't have so many, but very easy to make a mistake. And I think for the moment that concludes our F5 101 introduction, having gone through virtual servers, pools and nodes. And remember, peek twice, poke once.